Alright, so we are continuing on with lesson 4.6. And since there wasn't an investigation for lesson 4.6, I decided to just do a little introductory video, explain the examples in the textbook. That way in class we can practice using this a bit more. A lot of what we're going to do with 4.6 is set up proofs. Now, when I was growing up, we had two-column proofs. Your textbook talks about paragraph proofs, and lesson 4.7, which we're going to skip actually, talks about flowchart thinking. Basically, when you have a proof, you are just justifying in a reasonable, logical order your solutions to an answer. The only conjecture, really, that's not even really a conjecture so much as it is just kind of a statement. It's a summary of what we've discovered from proving two triangles are congruent. If we've done the shortcuts of using side, 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 or side, or angle, side, angle, if we've proven the two triangles congruent, well then we know the corresponding parts are congruent. But to help us simplify that in the terms of a written proof, we can use the abbreviation Cpctc, which just basically stands for corresponding parts of congruent triangles are congruent. Let's take a look at this in action. So our first example. Now, when I copied this down, I wasn't able to use the snazzy little characters, so add in the appropriate symbols. Is line segment AD congruent to line segment BC? All right, well, step one is to figure out if the triangles are congruent. So we have to go through our information and go step by step to kind of prove what's going on here. So the way I'm setting it up, and it's a little bit different than how your book does it. It's a bit old school, but it's a great way of like kind of pre-working your written proof. Instead of it being a paragraph, this is kind of like a rough draft. You're outlining what steps you took, and then you could spice it up and make it more appropriate by putting it into complete sentences. All right, right off the bat, we can see all sorts of congruent things going on. First one is that we notice that angle 1 and angle 2 are congruent, and the reason why we notice that is it's given information. So you can just say given. All right, the information was given to you, you didn't have to discover it, you didn't have to use a conjecture. Well, I take that back. That technically is not given to us because it's not using congruency signs. What this is the vertical angles conjecture. So, careful, don't rush too quickly because it's not technically given. But the vertical angles conjecture tells us those two angles are congruent. All right. Now we can say given, and I really hate it when it does that random line. Okay. Next thing we notice is that MA is congruent to MB. Now that's given to us because of the markings. So here I can say given to make more sense. All right. And step 3, angle A is congruent to angle B, and again, that's given to us. I didn't have to determine that, I just looked at the symbols. So now it looks like I have angle, side, angle. So, angle, side, angle, that's matching up. Angle, side, angle, yep, good to go. Since it likes to do those lines if I do dot, 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 so maybe I've discovered something. Okay, let's simplify. Maybe not. Let's simplify. Triangle MAD, again going in order, angle M to angle A to angle D, is congruent to angle M, congruent side, angle B, so triangle MBC. And we know that the reason why we can say those two triangles are congruent is because of the conjecture angle, side, angle. Then finally, ideally you'd be writing smaller with more space, we can say that AD is congruent to BC, and the reason why is because of corresponding parts of congruent triangles are congruent. So CP, see if I can get this pen to actually cooperate, Cpctc. And that's our proof. Now, in a sentence form or paragraph form, you put those sentences, you put all this proof information into complete sentences. But again, it kind of gets you going through logically using common sense to organize your thoughts. And the good news is you can actually work it in a couple of different ways. So you didn't necessarily have to go in the order I went. You could have gone in a different order, and that would have made, again, your proof would have shown your work and how you got your answer. All right, so next let's take a look at is line segment AE congruent to line segment BD. So first thing you want to do is take a look at where those line segments are. AE is this segment right here. And looking at the pictures of the congruencies, this is the triangle I'm working with. I would like to change colors. Right there, I want the orange one. Thank you. All right, and line BD, line segment BD, is this one right here. And looking at the pictures of where my congruent angles are, that's the triangle I'm working with. Okay. So let's use that to try and organize what our proof would be if this is able to be proven. All right, so, wait, just move it. There we go. So here's our work on one side, and then our proof or reason why is on the other side. Probably reason's a better word to use, but whatever. All right, step one, let's go with the easy ones. Angle DBA is congruent to angle EAB. And that's a given. The markings there tell us that. This is angle DBA, and this is angle EAB. We also know that angle BDA, so rearranging the numbers of the letters just a little bit, is congruent to angle AEB. And again, that's given to us by the markings. So that makes it nice and easy for us. And then, of course, line segment AB of one triangle is congruent to the line segment of the other triangle because that is a shared side. Actually, I don't think we use the word shared. Let's use the word common. It is a common side. In math, common means shared. All right, so let's take a look at what we have. We have angle, angle, and a side. So we can say that triangle DBA is congruent to triangle, so DBA, so EAB, EAB, and the reason why is because of side, angle, angle. So side, angle there, and angle there. And then side, angle, angle. Let's make sure our angles are matching up, so I'm going to erase part of that, hopefully. Sometimes the technology does not want to cooperate with me, so let's see what's going on here. Get rid of that one line going across. Just want to make sure everything's matching up. Okay, so DB is this side here, and it should match up with EA. Okay, good. Because then angle E should match up with angle D. Angle A should match up with angle B over here. All right. Looks good. Okay, so now that we have proven that the two triangles that were previously in orange and pink, I believe, are congruent, now we want to ask ourselves about AE and DB. So AE is this one right here, and DB is this one right here. And because those do match up with our labeling, we can say that line segment BD is congruent to line segment AE. And I just rewrote it in a slightly different order because I had had one triangle on the left-hand side and the other triangle on the right-hand side, then it just keeps my information corresponding. So, and again, that's the rule we're going to use. Corresponding parts of congruent triangles are corresponding, or sorry, are congruent. So that proves this statement here. This is the final answer. And notice that it's a yes or no question, but you can't just say yes or no. You have to prove your answer. You can't just say yes, and that's it. Tell me why it's yes. If it's no, tell me why it's no. And that's pretty much it for this lesson. We'll have some practice on this in class. And then we will also conclude Chapter 4 with our investigation on 4.8. See you in class.